So in this video we are going to have a look at writing some numbers in polar form and then converting from polar form back to rectangular form. So polar form is anything that can be written as a complex number, obviously, that can be written in the form or cos theta plus I sine theta, where or is the modulus and theta is the argument. And then rectangular form can be written as a plus bi, so just standard complex form or complex number notation. Okay, so if we start here with part 1, we have z equals minus root 3 minus I. We'll find our modulus first. Into your calculator. Or equals 2. We'll draw a quick sketch of it then. So we sit here in Q3. There's or that we just worked out. So we can take both approaches here for figuring out theta. So that's root 3 and 1. So alpha is equal to tan inverse of 1 over root 3. And your calculator, and I'll put it in radians. Alpha equals pi over 6. So for approach 1, we have theta is equal to pi plus alpha. So theta is equal to pi plus pi over 6. And approach 2. We find alpha again. And then this is where we make our answer negative. So it's pi minus alpha. And make your answer negative. So theta is equal to minus pi over 6. Pi minus pi over 6 will give us 5 pi over 6. So then theta equals 5 pi over 6. So obviously our two answers here look slightly different, but both will be accepted. So we get z. Remember, this is where we want our complex form or polar form. So we have z is equal to, or we figured was 2 cos 7 pi over 6 plus I sine 7 pi over 6. For this one here, we get z is equal to, the modulus stays the same, and cos minus 5 pi over 6 plus I sine minus 5 pi over 6. And there's your answers. Again, it just depends which approach you use, but always we can double check our answer. So in your calculator, if you put in 2 cos 7 pi over 6 plus I sine 7 pi over 6. So work out the value of cos 7 pi over 6 and sine 7 pi over 6, multiply by 2, and you'll get z equals minus root 3. And then the sine of 7 pi over 6 will give you minus a half. You multiply that by 2 and you get minus 1. If we check back up, that was our original number, so we're okay there. And if we check our second method, into your calculator, 2 cos minus 5 pi over 6. And we will get, so cos of minus 5 pi over 6 by 2 will give you minus root 3 and sine of minus 5 pi over 6 by 2 will give you minus 1i. So there's two slightly different answers based on the approach, but at the end we'll give you back the same answer. Okay, so that's part 1 done. And part 2. We've been given 3 minus 3i. Okay, so first step we get our modulus. That'll give us back 3 root 2. Next we're going to get the argument. So a quick sketch. So we have 3 minus 3i. There's our 3 and 3. And so for here now, I will take approach 1 for this example. So that's theta equals 2 pi minus alpha. So alpha is tan inverse of 3 over 3. So we get pi over 4. So then theta is equal to 2 pi minus pi over 4. So for theta, just safest put these into your calculator. You can do them in your head too, but just for peace of mind. And then to set up our polar form, or is 3 root 2 all on cos of 7 pi over 4 plus I sine 7 pi over 4. And there we go, we're in polar form. Part 3 now. We had minus 4 plus 4i. So to find our modulus, so into your calculator, and we get 4 root 2. Quick sketch now to get our argument. And I'll use approach 2 on this one, which same as approach 1 because we're in Q2. It's pi minus alpha. Alpha is tan inverse of 4 over 4. So for alpha we get pi over 4, and then theta is equal to pi minus pi over 4. So theta equals 3 pi over 4. I have theta, I have or, so we can set up our complex number. So it's 4 root 2 on cos of 3 pi over 4 plus I sine 3 pi over 4. That's part 3 answered. And then part 4. Our complex number is 2 plus 2i. So for the modulus, it'll be the square root of 2 squared plus 2 squared. Into your calculator. Or it goes 2 root 2, quick sketch. We're in Q1 here, so it's pretty straightforward. Here's my modulus. My angle as is 2 and 2. So for both approaches it's the same here. So for theta we get pi over 4, and into complex, polar form, sorry, get z equals 2 times cos pi over 4 plus I sine pi over 4. Okay, so that's parts 1, 2, and 3 here. So this here was approach 1. Okay, and if we look up, then we have the second parts where we were asked to write the following numbers in rectangular form. So we're converting from polar form back to rectangular form. So we have z equals root 2 cos of pi over 4 plus I sine pi over 4. So keep your root 2 there for now. Into your calculator, make sure you're in radians. Cos of pi over 4 will give root 2 over 2 plus sine of pi over 4 will give again root 2 over 2. Root 2 over 2 multiplied by, we have root 2 over 2 times root 2 will give back 1 plus 1i. So that's it back in rectangular form. And for part 2 then we have root 3 cos of pi over 6 plus I sine pi over 6. Keep root 3 where it is for now. Into your calculator, make sure you're in radians again. Cos of pi over 6 is root 3 over 2. Sine of pi over 6 is a half. So, and multiply them out. So root 3 multiplied by root 3 over 2 will give us 3 over 2. And then root 3 multiplied by a half will give me root 3 over 2i. And there's your answer in rectangular form. And that's those examples done.